Hello, here I will cover some concepts from section 7.5, right angle trigonometry. First, I would like to cover a couple of proofs. So the first one is that sine of 90 degrees minus alpha is equal to cosine of that same angle alpha. Okay, so if we have any type of right triangle with interior angles of alpha and beta, then in this triangle, I am denoting that lowercase a is the side opposite angle alpha, and lowercase b is the side opposite angle beta, and side c is the side opposite the right angle. So notice that sine of alpha is opposite over hypotenuse, a over c, and cosine of beta is adjacent over c. So therefore, sine of alpha is equal to cosine of beta, because AC is equal to AC. Additional to this, notice that alpha plus beta plus 90 degrees equals 180 degrees. This is because the sum of the three interior angles of any triangle need to sum up to 180 degrees. And the little box in the corner is a 90-degree angle. Now, this implies that alpha plus beta, these interior angles, alpha plus beta equals 90 degrees. And then we can subtract beta from both sides, and this says that alpha is equal to 90 degrees minus beta. And if we were to subtract alpha from both sides, this is also saying that beta is equal to 90 degrees minus alpha. Therefore, sine of alpha is equal to cosine of 90 degrees minus beta. I'm sorry, sine of alpha equals cosine of 90 degrees minus alpha, and cosine of alpha is the same thing as sine of 90 degrees minus alpha. Okay. Another proof that sine squared x plus cosine squared x equals 1, or sine squared alpha plus cosine squared alpha. These angles need to be the same angle. So if we look at sine of alpha is a over c. And so we're going to square that, and we have and then cosine of alpha is going to be adjacent over hypotenuse, or b over c. And we're saying that this is equal to 1. Okay. Square these out. When you add or subtract fractions, you need the same denominator. Here we have the same denominator, so this is the same thing as and the same non-zero number divided by itself is equal to 1. So if this equals to 1, then the numerator has to equal the denominator. This tells us that because the numerator is equal to the denominator. A squared plus b squared equals c squared. That's the Pythagorean theorem when you have a right triangle. The sum of the squares of the two legs is equal to the square of the hypotenuse. Okay. This is the fundamental identity of trigonometry. Sine squared alpha plus cosine squared alpha equals 1. We will use this a lot. Let's go to solving some problems. On page 511, we have, on page 519. Page 519, we have some diagrams. So in this triangle, we have theta, and the side opposite theta is 2x. We have alpha, side opposite alpha is 3. So we can use Pythagorean theorem and find the hypotenuse. The same thing with the second triangle and the third triangle. We will use the Pythagorean theorem 3 times to find the missing pieces of the triangle, and then it'll be easier to solve our problems after that. So this here we have if we label our hypotenuse as C. Remember here we're going to be squaring all of this. This is 2x times 2x, which is 4x squared plus 9. Take the square root of both sides. And I prefer the x squared to be in front of the constant. Okay, similarly, let's find out what happens over here. If we label this as B, four x squared is 16x squared, and then subtract 9 from both sides, and then take the square root of all of it. So this is and then let's call this A to find this length. So what we have a right triangle. So we need this whole length squared plus this whole length squared is going to equal the hypotenuse length squared. So this implies okay. And then we can subtract x to the fourth from each side. We can subtract 1 from each side. A squared is on the left, so let's add 2x squared to both sides. Okay, so A is equal to 2x. And now we can solve some of these problems. So cosecant of alpha, that's your 1 over sine. Cosecant of alpha, there's alpha. So we want the inverse of sine. So this is going to be an unusual number, but sometimes we have unusual numbers in math. Secant is the cosine component. So secant, the same hypotenuse, and our denominator is going to be 2x because the cosine is the adjacent over hypotenuse. So the secant will be the inverse. Cotangent is cosine over sine. So we have the cosine over sine. Then we need sine squared alpha plus cosine squared alpha plus tangent squared alpha. Okay, well this here is equal to 1. So this is the same thing as 1 plus tangent squared alpha. And I think that's one of the identities. So if we have s plus c equals 1, tangent is sine over cosine, divide everything by cosine, and so we get tangent plus 1 equals secant. So this is the same thing as secant. Secant of alpha. But we established the secant of alpha was this number. They're the same number. Sine of phi. So sine of phi is going to be opposite over hypotenuse. And the numerator is a difference of squares, but the denominator can only be factored in the imaginary numbers, so I'll leave that alone. Cosine of phi. Cosine is adjacent over hypotenuse. Tangent is sine over cosine. Since they have the same hypotenuse, it's just going to be the y component over the x component. And again, that cannot be simplified. Okay. So now we need cosecant of phi times secant of phi times cotangent of phi. Let me clean that up a little bit because that looks troubling. So this is so here the cosines simplify out. So this is the same thing as 1 over sine squared of phi. Or the inverse of sine squared. Which is cosecant. So I'm going to erase this to give me some working space. So I need cosecant squared of phi. Okay. So we're going to take cosecant is the inverse of sine. So it's going to be this over this squared. Okay, let's distribute this out. It's the numerator times itself over the denominator times itself. So that when you FOIL the numerator, we have, and the denominator, and as much as this looks like you would like to factor it, this does not factor. This does not simplify. Because if you look at the numerator here is just a product of these two. And these two are not factored in the reals. Therefore, your final conclusion cannot be factored in the reals. So this cannot be simplified. Okay. Sine. This is the same thing as cosine of phi. So cosine of phi is going to be adjacent over hypotenuse. And cosine of this is the same thing as sine of phi. Sine of phi is opposite over hypotenuse. As you look at the triangle, any generic, so tangent of alpha is going to be the sine over cosine. Cotangent of beta is cosine over sine. So just as these are supplemental angles, as well the tangent and cotangent, secant and cosecant. And so this is the same thing as cotangent of phi. Cotangent is your cotangent is your cosine over sine, your x over your y. So it's the cosine over sine, it's the adjacent over opposite. This was just for more workspace. Thank you very much. Please go to tutoring.